A 2I plus 1J plus 4K newtons per coulomb electric field passes through a Gaussian surface that has an area surface normal vector of 8 meters squared that points in the negative y-axis direction. How much electric flux passes through the Gaussian surface? Okay, so before we begin, we want to remember the equation to find flux, which is equal to phi. This is the Greek letter for phi, equals the dot product between the electric field and the surface area vectors. Okay, so now let's find our E and A. So we have E over here. Let me label them. So this is electric field, and this is surface area. And these arrows just means that they're vectors. Okay, so let's find the electric field vector. We know here that the electric field vector is going to be this. So we have 2I plus 1J plus 4K. Okay, now we want to find the surface area vector, and we know that the field passes through a Gaussian surface that has an area surface normal vector, so we know that we can turn this into a vector that points in the negative y-axis direction, okay? And so whenever you turn anything into IJK format, vector format, I stands for x, j stands for y, and k stands for z, okay? So since it has 8 meters squared pointing in the negative y-axis direction, it's only going to have the j component. So everything else is a 0. So I is 0 minus, because in the negative y-axis direction, 8j plus 0k. Okay? Now we want to find the dot product between E and A. And when you find dot products, you're going to multiply them, but then the result is going to be a scalar. So scalar means that it's just going to be one number. Vector means that you have IJK format, okay? So this is going to be scalar, meaning it's going to have a result of only one number. So you multiply these two, the I components together, the j components together, and the k components together. So 2 times 0 is 0, plus a negative 8 times 1 is negative 8, plus 4 times 0 is 0. So you have this, okay? So the dot product between E and A, the electric field and the surface area, is going to be equal a negative 8, which means that phi, or the flux, electric flux that passes through the Gaussian surface, is going to be a negative 8 newtons per coulomb meters squared. And there you have it.